In this video, we'll do the inverse of a 2 by 2 matrix. In this example, here we have let A equal this square matrix, this matrix 2 by 2 matrix, 3, 1, 4, 2, and this the same thing square matrix. Find if possible A inverse, B inverse. So in this video, we'll concentrate to find the inverse of 2 by 2 matrix. So here, let's read the definition here. The matrix A, n by n. So here you can see it has to be square matrix. If it's not square, then A inverse, it will not exist. So here, n by n matrix is non-singular or invertible. Some people, they called it non-singular, and some people, they called it invertible. They have the same meaning. If and only if, this if and only if, it's like this symbol, if and only if, there exists a matrix A inverse such that A multiplied by A inverse equal to A inverse multiplied by A equal to the identity. The most important here to know that if you multiply A by the inverse, then you will get identity matrix. Let's read this two important note here, which illustrate or summarize the definition. If A inverse exists, then A is non-singular, or they called it invertible. And the same thing, if A is non-singular, if they give you A is non-singular, then you have to know that A inverse exists. And the same thing here, if A inverse does not exist, then A is singular. And the same thing, if A is singular, or the same meaning here, not invertible, then A inverse does not exist. So you have to know, if they told you A is non-singular, then you have to know that A inverse exists. So these important two notes. So now here, how we find inverse? These two matrices. Here the same thing, 2 by 2. How to find? Let's write up about how to find the inverse of a matrix. Let's go up now. To find, let's change the color. A inverse. How we can find it? The first way to find it, A inverse, let's change the color, equal to 1 over determinant of A multiplied by adjoint, or they called it adjugate of A. This called adjugate or adjoint. And sometime in the future, we will explain in details how to find this adjoint or adjugate of A for 2 by 2, 3 by 3, or 4 by 4, or any square size to find the adjugate later. But here in this video, we will concentrate about how to find it for 2 by 2 matrix in easy way. Here, in case A is 2 by 2 matrix, just we have to remember it. Let A, let's say A equal, let's change color again here. Let's change it to orange color. So here A, and let's say here D. Let's change the color to the green. Let's say here B, and here C. Then A inverse equal, it's very easy to find it, 1 over the determinant of A, and here the matrix here. Let's change the color. Just swap these two. So here D and here A. Let's change the color to the green. And here you have to multiply this by negative. So negative B. And the same thing, you have to multiply C by negative. So here it will be negative C. Let's close the bracket for this matrix. So here we have this, the inverse of A by this formula. And of course, later in details, we will explain how we find this in details. In sometime in the future, we will explain what is the adjoint or the adjugate of A. So here, the same here. This is the adjugate or adjoint. But for 2 by 2, just remember this formula. And what is the determinant of A? Just I will explain it here. Just you have to multiply these two minus these two. So A multiplied by D. So this equal A multiplied by D minus B multiplied by C. B multiplied by C. This is the determinant of A for 2 by 2 matrix. Now, let's write note about this. Note 1 and 2. Let's change the color. Here, the first note here, the determinant of A, if it's not equal to 0, then A inverse exists. And the same thing, if A inverse exists, then the determinant of A not equal to 0. So we put here if and only if. So either way, the determinant of A not equal to 0, then A inverse exists. Or if the question said the A inverse exists, then you have to know that the determinant of A not equal to 0. If the determinant of A equal to 0, then A inverse does not exist. And the same thing, if A inverse does not exist, then the determinant of A equal to 0. These very important to note, to know, to find the inverse of any matrix. Here, the second way. A, then the augmented line, and here I will write the identity matrix. Here I wrote n because any size of any size of the matrix. If it's 4 by 4, so here it will be 4. Here I will close this bracket. So if you can change it by RREF, Reduced Row Echelon Form, by elementary row operation. Here, if you can change this one to identity, if you can change it to the identity here, then here you will get the A inverse. Then you will get here the A inverse. And the same way, I'll write it here very quickly. RREF. I will just fill it by the other color. I have changed the color to the blue. The same thing here. If you have here A inverse, and here if you wrote here the identity matrix, then if you change A inverse to identity, then here you will get A. So these are very important to know to use this method. Note 1 and 2. 1, if you can change A by using RREF, if you can change it to identity matrix, then here A inverse exists. And the same thing here. If you have A inverse exist, then you can transform A to identity matrix. So you have to know this thing. And also here the opposite way, RREF. If you couldn't change A to identity matrix, so I will put not equal to identity matrix, then A inverse does not exist. And the same thing will apply if A inverse does not exist, then you cannot transform A to identity matrix. Also here I will write important note. If A is not a square matrix, not square matrix, it means like 2 3, not 2 2, or like here different size, not square matrix. If it's not square matrix, then A inverse does not exist. So here this two method here, we will use it down here. So here we have two method, 1 and 2. So either this or this, you will have full mark for your question. So let's go down. Let's solve this. Now let's solve number 1. We will solve number 1 by 2 method, and the same thing 2, we will solve it by 2 method as we mentioned it up. So just to confirm how we will use the first method to find this A inverse, so just we have to use this formula. We have to use this formula, and we have to start from here. So if the determinant not equal to 0, then A inverse exists. If the determinant of A equals 0, then A inverse does not exist. So just we will start by this one. And the determinant of A, this one here. The determinant of A, this one. So just A multiplied by D minus B multiplied by C. So let's write the rule here again. If A, for example, A, B, C, D, then A inverse equal 1 over the determinant of, and here we have to swap these two. So D, A, and put negative here, put negative here. So minus B minus C. And for the determinant of A here, this equal to this multiplied by this, A, D minus this multiplied by this, B, C. So now here the determinant of A equal 3 multiplied by 2. So here 3 multiplied by 2, 3 multiplied by 2, here minus 1 multiplied by 4 equal 3 multiplied by 2, which is 6, minus 1 multiplied by 4, which is 4, and this equal to 2, which is not equal to 0. Since the determinant is not equal to 0, then A inverse exists. So here, therefore, A inverse equal to 1 over the determinant which is here 2, multiply by, just here we have to swap these, the diagonal here, just we have to swap it. So 2 3, it will be 2 3, and here we have to put here negative and here negative. -1, -4, and we know the determinant is equal to 2, so 1 over 2, 2, -1, -4, 3. Now this number, it will be multiplied by each element inside this matrix. So half multiplied by 2, half multiplied by -1, half multiplied by -4, half multiplied by 3. Equal. Here it will be 1. Half multiplied by -1, which is -half. Here 4 with 2, it will be 2 here. So half of 4 is 2, and here negative, so -2. 3 multiplied by 1 over 2, it will be 3 over 2. So here our answer. So we solve number 1. Another way to solve 1. So let's write it here in blue as well to illustrate these are the same. So just we illustrate this one more. So here we finish. So we have finished here to solve question number 1, but we want to solve it by another way to solve number 1. So another way, as we mention it up, we will use this method. So A, and here we have to put identity since this 2 by 2, so it will be here 2 equal. So we have to transform A by elementary row operation, or you have to apply RREF, Reduced Row Echelon Form, to change this A to identity matrix. So let's write A 3 1 4 2, 3 1 4 2, and here the line of the augmented, and the identity 1 0 0 1 1 0 0 1, the identity here. As we know before, it's like stair, or it's like snake game. Just like you have to walk, then you have to find this number, so you have to make this one 1, then you have to go down, you have to make it 0, then you have to walk until you find number, then you have to make it 1, then if you make it 1, then you have to make the up of this number to make it 0. So just remember how to apply RREF. So just here we have to multiply by 1 over 3 to make this number equal to 1. So 1 over 3 multiply by row 1 in row 1. So 1 over 3 multiplied by 3, which is 1. 1 over 3 multiplied by 1, which is 1 over 3. And here the line of the augmented matrix. 1 over 3 multiplied by 1, which is 1 over 3. 1 over 3 multiplied by 0, which is 0. Let's close the augmented matrix. And the second row, it remains the same. 4 2 0 1. Let's change the color. So here we make this one 1. So now we have to make this number equal to 0. So row 2 minus, we have to multiply by 4 here, because 4 minus 4, which is 0. So 4 row 1 in row 2. This row, it remains the same, so we will write it in very fast way. Now 4 minus 4 multiplied by 1, which is 4. 4 minus 4, it will be 0. 2 minus 4 multiplied 1 over 3. So let's write it here. 2 minus 4 multiplied by 1 over 3 equal 2 here minus 4 multiplied by 1 over 3, which is 4 over 3. Let's make this 2 6 over 3. 6 over 3 minus 4 over 3 equal 6 minus 4, which is 2, so it will be 2 over 3. So the answer will be 2 over 3 here. 2 over 3. Here 0 minus 4 multiplied by 1 over 3, so it will be minus 4 over 3. Minus 4 over 3. 1 minus 4 multiplied by 0, which is 0. So it will be 1. Now we have to make this one 1, because here this 1, so 1, you go down, then keep going until you find 1. So we have to make this one 1. So 3 over 2 multiplied by row 2 in row 2. We will write this row very fast way because we will not change anything in the first row. Now here 3 over 2 multiplied by 0, which is 0. 3 over 2 multiplied by 2 over 3, which is 1. 3 over 2 multiplied by negative 4 over 3, it will be this one, it will go with this one, and this one with this one, so it will be negative 2. I will illustrate it more here. So 3 over 2 multiplied by negative 4 over 3. So this, it will disappear with this, and this one with this one, it will be here too. So negative 2, it will be the answer. Negative 2. 3 over 2 multiplied by 1, which is 3 over 2. You can see it's very long way to find the inverse for 2 by 2 matrix, so I really suggest you to find it by this formula. This very long way to find the A inverse. So here 1, here 1, so we have to make this one 0. So row 1 minus, so 1 over 3, it should be minus 1 over 3. So 1 over 3 in R2 and R1. Let's change the color. So this row remains the same, so I will write it here. 1 minus 1 over 3 multiplied by 0, which is 0, so it remains 1. 1 over 3 minus 1 over 3 multiplied by 1, which is 1 over 3, so 1 over 3 minus 1 over 3, it will be 0. 1 over 3 minus 1 over 3 multiplied by negative 2. Let's write it here since it's complicated a little bit. So 1 over 3 minus 1 over 3, 1 over 3 minus 1 over 3, which is here, multiplied by negative 2, equal 1 over 3. Minus with minus, it will be positive 2 over 3. And here it will be 3 over 3, which is 1. So here we have 1. 0 minus 1 over 3 multiplied by 3 over 2. So 0 minus 1 over 3 multiplied by 3 over 2 here. So this one goes with this one, so it will be negative half. negative half. So here we reach this identity, and here the A inverse. So finally we reach the answer. Therefore, A inverse equal to 1 negative half negative 2 3/2, which is the same as this one. So we solve it by two-way and we got the same answer. Now let's confirm our answer since we got the same answer. So let's write it here. Just here, as we did, we finish. Just now we want to confirm. To confirm A inverse is the inverse of A. Here just we want to confirm it. This is just to make sure our answer is correct. To confirm it, just we have to follow this from the definition. A multiplied by A inverse, it has to be equal to identity. So A multiplied by A inverse, A, which is here 3142, 3142, and the inverse as we get it here, 1 negative half, negative 2 here, 3/2. Now let's multiply them. So this row by this column, so 3 multiplied by 1, which is 3, plus 1 multiplied by negative 2, which is negative 2. Now this row by this column, 3 multiplied by negative half, which is negative 3/2, because just we multiply this. 3 multiplied by 1, which is 3 here. Now 1 multiplied by 3/2, so here plus 3/2. Let's close this bracket for the matrix. Now this row by this column, 4 multiplied by 1, which is 4, plus 2 multiplied by negative 2, which is negative 4. Now this row by this column, 4 multiplied by negative half, which is negative 2, because 4, it goes with this 2, it will be this 2, and here the negative, so it will be negative 2, plus 2 multiplied by 3/2, which is 3, 3 plus negative 2, which is 1. Here, this one, it becomes 0. And the same here, it will become 0. Negative 2 plus 3, which is 1. So we find this equal to the identity matrix, which is 2 by 2. So we have finished. And we confirm that our answer is correct. So you can use this method or use this method. So here, use either way to solve number 1, this way or this way, and to confirm your answer by this way. Now let's find the B inverse. B here, let's find it. So number 2, now we will solve number 2, the determinant of B. The determinant of B, how to find the determinant of B? So as we did here, the determinant, so just multiply this by this, minus this by this. So 4 multiplied by negative 2, minus negative 8 multiplied by 1. So 4 multiplied by negative 2 first, 4 multiplied by -2 minus -8 multiplied by 1. -8 multiplied by 1. So here 4 multiplied by -2, which is -8. Negative with negative, it will be here positive, and here it will be 8. And this one equal to 0. And we know that if the determinant is equal to 0, then we can't find the inverse of this matrix, as we did here. If the determinant equals to 0, then A inverse does not exist. The same thing here. We'll write since the determinant of B equal to 0, then B inverse does not exist. Now we finish. Now we have answered this question that B inverse does not exist. Let's try to solve it by the other way. The other way, like what we did here, the same thing as we did here. So another way to solve 2. Let's write here B, then here identity matrix, which is 2 by 2, since B is 2 by 2 matrix, equal, what is B? 4, -8, 1, -2. 4, -8, 1, -2. And the identity matrix 1, 0, 0, 1. So now we have to make this one equal to 1. The easiest, since this one here equal to 1, so we can swap these two rows. We can swap these two rows, and instead of divided, then make this one 0. So just, it's easy to swap these two rows. So row 1, swap it with row 2, which is very easy way to solve it. So here I have to write 1, -2, 0, 1 in this row. And in the second row, I have to write this row. So here we have this one 1. So now we have to make this one 0. Now row 2 minus 4 row 1, because 4 minus, it should be here 4 to make this one 0. 4 minus 4 multiplied by 1, which is 4. So 4 minus 4, it will be 0. -8 minus 4 multiplied by -2. So -8 minus 4 multiplied by -2, which is -8 plus 8, which is 0. So here we have 0. So here we have 0. Here 1 minus 4 multiplied by 0, which is 0. So here it will be 1, because 1 minus 0, it will be 1. 0 minus 4 multiplied by 1, which is -4. Because here I will write it again here, 0 minus 4 multiplied by 1, which is 0 minus 4, which is -4. And this row, it remains the same, 1, -2, 0, 1. As you can see here, we have a 0 row, so we can't transform this part before the line of the augmented matrix. We can transform this one to identity matrix, so we stop here. So let's say C equal to this part 1, negative 2, 0, 0. So here, since C, which is this one, we call this part, since C has a row of zeros, we stop and conclude that B inverse does not exist. So here we finish and we conclude that B inverse does not exist since we have here a zero row. So in question 2, we can solve it in either way, this one or this one. And the same thing here, A, we can find it by this way or this way. And of course, for 2 by 2 matrix, it's better to find it by this formula, as we did it here and did it here. That's it. I hope this example it's clear for you, and in the next video we will solve 3 by 3 matrix and we will use this way to solve it, but in sometime in the future we will use as this method for 3 by 3, and we have to explain what is the adjugate or adjoint of the matrix to find the A inverse. That's it. See you in the next video.